Here's Brian Deen, software developer.
So, except for my comrade in arms here, who here works in the software industry or does anything with software? Yeah, okay, so I have an audience of one. Awesome. Okay, well, we'll just wing through this. So yeah, my name's Brian Deen. Where's the clicker? One clicker. There we go. Obviously, I'm a software engineer in the Seattle area. Did I do this right? Yeah, which one's forward? They're left and right. Oh, there we go. All right, so I graduated from Tech in '88. I've actually been writing code for a lot longer. I've been writing code since I was 11 years old. So I've been coding for 40 years. You can add that up. I've worked for a bunch of different companies, or a handful of companies in the Seattle area. The one I've worked for the longest is Microsoft. I worked there for 15 and a half years, from 1990 to the end of 2005. And then I did what everybody else did around that time and retired. But one thing that's really interesting about working for that long and writing code for all that time, retirement just sort of sucked. So I, of course, within like 3 months, went back to work. And I ended up helping out Microsoft with their Department of Justice antitrust case. So that was really an interesting piece of work. And that's what was my first company that I built. And that was just so that they had it. They couldn't actually use employees for some of this stuff, so they had to hire companies to do this and wouldn't hire individuals. They only could hire companies, so I had to do that. And then after I did that for Microsoft for a few years, then I went over to Amazon. And I was a principal engineer in Amazon Web Services, and I worked in the S3 group, which is their large storage system. And when I say large, you have to understand exactly how big this thing is. I mean, I'm not going to tell you exactly how big it is, but we were dealing with exabytes of data. So there's terabytes, there's petabytes, and there's exabytes. And when I say exabytes, I don't mean one. There were many, many exabytes and trillions of objects. And so you have to build a system that can manage all that. So I helped them do that. And then after spending my requisite time at Amazon and learning a lot, I went and worked at Valve, and they do video games. In particular, they do video games like Counter-Strike. They have a software distribution system called Steam, worked on that for a while. And then I quit that, and I started my own company again, and this time in downtown Seattle. So it's been kind of fun. The other thing I did at Amazon, in addition to being one of the principal engineers there, I also ran a business there, which was my first real foray into sort of understanding metrics and how to deal with businesses and talk to customers and things like that. Okay, so that's kind of what I did. So this talk is actually sort of a little bit of an homage to one class that I took at Tech that really was probably the most useful class that I have ever taken at Tech in my field. And that was, I think it's CS 326 now, but it was software engineering. And it's the one class that actually probably prepared me the most for when I got out to work. Knowing how to code, wasn't particularly, I already knew how to code. What did I do there? Knowing how to, all the different languages, that wasn't a big deal either, but learning all these tools was a big deal. And having had no other classes at Tech that taught any of these tools, it was pretty important for me when I got into the industry that I could sort of hit the ground a little bit better than I did before. Oh, one other company I used to work for. I used to work for McDonnell Douglas Helicopter Company, and they're no longer a company. And I worked in flight simulator and flight simulation. And it's really kind of interesting. Back in the 80s when we were developing this system, we had VR, virtual reality. We had large multiplayer simulations where everybody was interacting together. We were all running remotely. So we were networking with the guys who ran the tank simulators down in Texas. We were in Mesa, Arizona. We were talking to the guys in St. Louis who flew the jets, and we're all flying in one big happy simulation together. So a lot of the tech you hear about today is with games. It's been around for a long time. We even did the simulation for the International Space Station docking station, which was really cool. That was all in 3D. Okay. Yeah. Okay, so the first tool I want to talk about in software development are these project tracking tools, management tools. Basically what happens when you have a product, say you're working on a Microsoft Exchange server, which is one of the things I did work on, and you want to add a bunch of features to it, you have to sort of like break down the features, list them all out, break those down into work items, and then track everything. We actually make the developers kind of put that information in, as well as we make them update their data. And we measure that, right? So we know whether we're going to try to hit a date or be able to get this thing to a customer in time. And the tools we use are things like Microsoft Project, which honestly no one really uses. Jira, which is an open source tool that you can just sign up for and add to your system. Most developers hate this stuff. If you're writing code, all you want to do is really write code. But in management, you have to know whether you're making progress or not, so we kind of do require them to do that. And again, you're not writing code, you're just simply updating data and inputting data all the time. There we go. And of course, once you write a piece of code, you check it in, and we start working with it, invariably there are bugs. You try not to have bugs, that's one of the reasons we try to track everything, but as soon as you put a line of code in, you're going to probably introduce a bug somewhere in the system. And so we have to track all of that. A lot of work, especially towards the end of a project, before you ship, it's all driven out of the bug database. And I apologize for you guys don't actually write code, but this is actually kind of the thing that I think developers live and die by, is basically writing the code. And if you guys don't know what dogfooding, have you guys ever heard that term? Anyone? Yeah. So dogfooding basically means that you're running your own software. So if you're working on, say, a database like SQL Server, which I also worked on, and you have a relational database application, you're going to run it on the piece of software that we built that morning. You're not going to run it on something that shipped 5 years ago and is incredibly stable. So we call that dogfooding. It comes from the phrase eating your own dog food. And examples of tools that do that, it's actually really kind of funny. Most companies actually don't, they either roll their own or they do them on like, crappy spreadsheets and stuff like that. But Jira is the same kind of tool you do project tracking in, is often used for bug databases. And there's a Team Foundation Services product that comes out from Microsoft that supposedly people use, but we never even used it internally, so. Oh, source control systems. So when you write code, the one thing you want to make sure of is that when you finish a piece of code, that it goes into the system and it goes in as a transaction. It goes in and is held permanently, and you know exactly what change was made to the code from who made it. So those are usually done by these source control systems. Generally, the thought is that you check in the code, right? So you write all your code, you compile it on your machine, you get it all working, and then you check it in, and you use a tool to do that, and it's one of these tools. What's really interesting, there's a whole bunch of tools that do this. What's really interesting is 2 years ago, I would have told you that all these different companies, Microsoft, Facebook, Google, Oracle, in fact, everybody was using their own versions of different check-in tools. But in the last couple of years, there's been a kind of a huge shift in the industry. For some reason, well, actually, I know why. Almost everybody is starting to use Git. If Git was a company, that would have been a great company to invest in. But as it is, it's kind of an open source. So GitHub is a company, but it's not really. No one's using GitHub necessarily. The other thing, and there are no students here, right? It's too bad, because one of the things that you like to see when you're looking at a resume is you like to see somebody put in a Git repo where they have written code, so you can go and look at their code rather than actually just having to interview them all the time. So I was going to advise students to write a bunch of code, put it up on GitHub or Bitbucket or whatever website you want to use. Instrumentation. This is a pet peeve of mine. It's amazing how much time we spend working on features and implementing capabilities into the system, and we don't instrument our code. It's always an afterthought. People think, oh, I'll shove it in on the end type of thing. absolutely the worst idea ever. As a software engineer, you need to instrument your code from the beginning. If you do not instrument your code, then you actually don't know what your code is really doing. You can debug it if you want, all that, but you actually need to be able to measure things like performance characteristics, how much memory utilization it's using, all that kind of things. At Amazon, it was incredibly important that we did this. We have thousands upon thousands of servers, and all doing different roles within the service that we're providing, and you can't just debug that stuff. And it's not like there's somebody walking around looking at these machines, and they certainly don't have monitors on them at all. So you have tremendous amount of instrumentation going on, a tremendous amount of logging that's going on, and we have automated processes that are going through there and crunching through these logs, and then we can sort of look at it and say, what's happening with this system? If you don't instrument your code, and if you don't think about it from the beginning, and you slap it on the end, those are really going to suffer, and you're never going to get it right. So you kind of have to build it from the beginning. There are a bunch of technologies that are worth implementing on. Perfmon has a bunch of APIs if you're using Windows, and it's what I know that your group looks at all the time. I put in built-in diagnostics. It's called BID. It's a patent that I worked on several years back. Another good one to use for building your metric systems on top of. As far as analyzing the data that comes back from these metric systems, metricing systems, most of the ones I have seen anyways have been homegrown. It's everything from relational database or big data database to a Excel spreadsheet. I've seen all sorts of different things to do that. But you have to do this. Auto builders. So normally, when you check in code and you're building a project, you might have a build team, you often have a build team, but you certainly have a build process. What auto builders are is they're an automated system that runs in the background on your network, is enlisted in your code and everybody else's code, and builds the code continuously. So if it, as soon as it finishes building, it syncs all the code again and it starts building again. And these things are used to make sure that the code's building, because the worst thing as a developer is when you sync up the code onto your machine from these servers and you go to build it and it doesn't build and you can't figure if it's you that broke it or if it was broken when it got there. But so these things ensure that they actually continue to work. And again, there's a couple of them. There's actually one called Auto Builder. When I was at Valve, we set these up when I was there. And you usually have one or more, and you certainly have one for each platform you're going to deliver on. So the software I worked on at Valve, we were already running on Windows. We had it working on the Mac, and then I helped them convert it to run on Linux. So they're pretty important. Code review tools. And again, none of this has to do with actually the writing of the code. This is all stuff that has to go on as a software engineer that you have to think about and have to have going on. So code review tools. There's actually kind of two ways to do code reviews. You can do it, actually 3 ways. There is an automated system, so your development environment won't actually let you check in code unless it passes its own automated tests. Microsoft uses that a lot, actually. They have their coding standards, and they, for example, the whole argument about tabs versus spaces in code, they decide for you. The bracketing style in C and C++ and C#, they tend to use K&R bracketing. So you can't actually have that bracket on a separate line, the open curly. And they enforce variable names, and they do all sorts of crazy things like that, and they won't even let you check that in without that passing. So that's the automated one. They also have manual code reviews where I'll ask Bill to review some code for me, and there are tools that make it really easy. You give it a change number, which is associated with the check-in that you're about to do, and it basically brings up a tool and it shows you the differences, and you get to comment right there in the middle of the tool. Very, very nice tool to use. Highly recommend it. 2 minutes, yes. Okay, whipping through here real quick. Oh yeah, this. I cannot express enough how important it is before you walk into your manager's office or your neighbor's office, you Google that stuff. You go look it up first, right? Don't waste people's time, right? By going and asking them, hey, what's the compiler switch to turn on debugging? Like, don't do that. Like, just go look it up. It's there. Google's a great API or a great search engine. Sometimes, though, you don't find the data, you do have to ask. And when you do that, do everybody in the world a favor and go write a wiki page article someplace and add it to this great indexer called the Google search engine. I can't express how important that is. You waste so many people's time doing this. And this is stuff I didn't cover. So there's a whole bunch of stuff. Bill could probably talk about testing infrastructure. Deployment tools, package managers. This is making sure that your software is running with all the other software that you purchased or found online correctly. You know exactly what versions are running where. Performance reviews. This is sort of a people management skill, but you, as a developer, when you're writing code, you end up actually having to spend time on your review, and it sucks, and it's boring, and it's horrible, but we do it. Documentation. So a lot of time when we write code, we want our code to be documented really well, usually as a wiki or maybe a Word doc or whatever. All the automated systems I've ever seen that try to do this never work. There's only one piece of documentation that has ever told you what the code's doing, and that's the code itself. So what we do instead is we actually end up having source indexers that you can go and look at, and you can look up source code. But no one uses Autodoc. I've seen it, we've attempted it multiple times in industry, it never gets used. And that's pretty much it, I think. Yay, sweet, finished. Any questions? Yes, sir.
Brian, what do you see on the horizon in regard to making hacking more difficult?
It's an arms race. It's just an arms race.
It's going to be there forever?
At some level. I mean, I think certain problems I think are solvable. You know, having everybody go to HTTPS as opposed to, or secure HTTP as opposed to just raw text HTTP. I mean, we got rid of basic authentication, which was almost plain text on the wire. I think ultimately, though, it's just an arms race, right? You can do all sorts of encryption, and ultimately it's about finding primes, and machines get faster and faster, and you find these. You're going to be able to crack these things eventually. But the one you'll never really get rid of is the social engineering aspects of it, right? Someone's going to be able to spoof you. They're going to say that they're your neighbor, and you're not going to know, right? They're going to call you on the phone and say they're from the IRS, but they're actually calling from India, right? So I don't know how you solve that specific problem. But as far as like getting into networks, you know, honestly, as data gets bigger and bigger and more of your information's online, I'm not sure that it becomes necessarily as valuable. There's just so much data out there, right? I'm talking about S3 holds, and they're only one of the players in this world. So at some point, it just becomes unfathomable to even pull all that data. What I think you will see more, rather than these general hacks where you steal all the Yahoo passwords, right? You'll start to see more very focused hacks. Like you'll find a victim and then they will hack that victim, as opposed to a general type of hack. So I think in the future, that's what we're going to have to watch out for.
Thank you.
Yeah. Anything else? Not that I know anything, but yes? Hacking? Oh, hack? Oh, like NetHack? How far did we get? Yeah, I think I finished. I think I got the amulet of Yendor. Someone mentioned mapping out the tunnels underneath tech. I actually wrote a game when I was at Tech that part of the game was adventuring through the tunnels underneath Workman Center and all those other places, and Jones Hall, turns out. Who knew? All right, any other questions? Okay, thank you very much.